Good morning. Glad to see you. Thanks for coming by this beautiful morning. A little foggy, maybe some rain throughout the day. Today we have a practice set that we're going to do on Delta Math, and I want to review these three different ways that we can write down um, linear equations. So forms of linear equations. There's three. Um, the one that we've looked at the most is slope-intercept form by a lot, right? It's not even close. And this is in, I think, section 6.1.1 if you want to review to this. But I'm going to come over here and write. So in slope-intercept form, we have this y equals mx plus b. And if we have an equation written in this form, we can just visually see what the slope pattern is for that linear function, and we can see the y-intercept where it begins. Another form is called standard form, and it looks like this: ax plus by equals c. And this variable b is not the y-intercept, right? It's not the y-intercept at all. It's just the coefficient of y. So if you look at it, what we observe is that, okay, I've got x and y both on the left-hand side written down, and I can see the coefficient of x is a, the coefficient, the thing that y is being multiplied by, is b, and there's a constant on the other side, c. So that's called standard form. If you have an equation that's close to standard form, like for example, you could have 2/3 x plus 5y equals 2. Some textbooks, some authors, some mathematicians will say this is not quite standard form. Standard form, we would like to have just integer coefficients, no fractions. It's pretty easy to make that transformation here. If I multiply both sides by the number 3, right, if every single term on both sides is multiplied by 3, this would become 2x plus 15y equals 6. So you can see I can take an equation, and if the last little bit is that I've got fractions and I want to get rid of them, I can do that. The form that you're going to practice mostly today, well, there's a variety of problems that you're going to do in Delta Math, but the ones that I think will be newish for you is I'm going to want you to write the equation of a line using something we're going to call point slope form. And in order to write the equation of a line in point slope form, well, you need a point, x, y, you need some point, and you need to know the slope. Now, because in a linear equation we already have an xy, I'm going to put subscripts on the x and subscripts on the y so I can differentiate between the variable and the parameter. The variable and the parameter. So our book uses, and you'll see this, they're telling you that the point that you have is the point hk, and this is not terrible, this is not awful, but I think it's more helpful for me if I call the point that I'm given x1 and y1. So I'm going to sub that out in the formula that you see that appears in your book, and I think you'll see that it sounds better when you write things down that way. So this is point slope form. It is, you take y and you subtract from that y the y coordinate at the point that you were given. So you can see I've written down y minus y1, or I sometimes will say the y value that I know. So y minus y1 equals the slope m times x minus the x value that I know. And it's like a simple example would be like, okay, let's say that I've got the point -3, 2, And I'll say that my slope, m, is 2/3. Well, with almost no effort, I can write down the equation of that line. I could write down y minus the y value that I know. The y value that I know is 2, equals slope, which is 2/3, times x minus the x value that I know. And yeah, I did write the two negatives there. Don't leave those for your final answer. Go ahead and fix that. So if you see that you're subtracting a negative, right, we're adding the opposite there. So I would finish this and just write y minus 2 equals 2/3 times x plus 3. And this is the equation of the line in point slope form. And I can see the slope, and I can also see a point that it goes through if I remember that this is minus the negative, right? So I know that it's going to hit the point -3, 2, -3, +2, and it's going to have a slope of 2/3. So let's consider two examples. We'll look at first the point 5, -9, and 5, 8. And the instructions are write the equation of a line in point slope form that will hit those 2 points. It will go through those 2 points. Well, I definitely have a point, right? I got all the points I could possibly need. What I don't have is the slope. So I'm going to go ahead and find the slope here, and I'll remember that it's going to be equal to the change in my y values divided by the change, the difference in my x values. So I'm looking at, I'll go ahead and take the second point, 8 minus -9 over 5 minus 5. And when I do that, this ends up becoming, that's positive 17. 8 minus -9 over 0. So this is a problem. The slope, it turns out, is not 0. The slope is undefined. And this happens when we have a vertical line. And now that I look a little bit more closely at my 2 points, I can see, oh yeah, look at that. The x values were both the same. That's kind of a good indication that that's what's going to happen. So because my x values are both the same, and I slowed it down and I looked at what the actual slope was, the fact that it's undefined, this is one of the cases where I will not write the equation of a line in point slope form. I simply can't. What I would have to write down is this is the equation, x is always the number 5. I can see it now, right? X is always 5. Well, x is 5 here, x is 5 here. So regardless of, the y's are going to be go up and down. That's why it's a vertical line, but x is always 5. So a little bit tricky, but I wanted to point that out, that is a possibility, right? If you're asked to write something in point slope form, it's possible that you could get a situation where it's a vertical line and you can't do that. Let's look at an example where perhaps that's not going to happen. We'll look at this. And we're going to find our friend the slope again. And in this case, I'm just going to go ahead and start with my second point. I'm going to start with this point and then go to this point. So I'm going to write 7 minus -7 over 8 minus a -4. So my numerator ends up being the number 14, and the denominator is 8 plus 4 is 12. So I know my slope, and I can see that I can reduce that. And if you can reduce your slope, you should. You should have reduced slope. So this is equivalent to up 7 units and to the right 6. So the slope pattern is up 7 over 6. And now you can see I've got two different points that I could pick. I could pick either the -4, -7, or I could pick the point 87. It doesn't matter which one I do. My answer will look different for sure. But if I was to ask, for example, Desmos to graph either answer, I would get the same exact line. And I could rewrite the equation in point slope form and say, yeah, those are the same line. But I'm just going to go ahead and use, well, let's do both. I'm going to start with the second point there. So let me remind you what we said. Point slope form is you're going to take y and you're going to subtract the y value from the point that you know, and then that will be equivalent to your slope m times x, and then minus the x value from the point that you know. So for the purpose of this, I'm going to say the point that I know is the 8, 7, the second point listed. So this equation would be y minus 7 equals my slope of 7/6 times x minus 8, and I'm done. So that's the equation of the line in point slope form. It's really it's fun. It's quick. It's quick to write that down. In fact, let me do the other point. I could write y minus -7 equals slope m, which is 7/6 times x minus -4. So if I clean that up, that's y plus 7 equals 7/6 times x plus 4. So my claim is those are equivalent equations, and if I graphed both, they would look the same. In fact, out of curiosity, I am going to graph both. So here are my 2 points. I've got the point -4, -7, and the point 8, 7. And I had written this down in two ways. The first way I wrote was y minus 7 equals 7/6 times the quantity x minus 8. And I can see that that successfully hit both points. And the other way that we wrote this down was y plus 7, whoops, not t, plus 7 equals 7/6 times, whoops, x plus 4. And I can see in entering both of those, right, I've clearly got the equation of the line. I've got 2 different forms of the equation, right, that's hitting the same point. Now, if I wanted to, I could, of course, distribute the 7/6 to both terms and subtract 7 here, or distribute the 7/6 to both terms and add 7, and I would get the equation of the line in slope-intercept form, and it would be the same. But this is a really nice way to quickly write down the equation of the line, point-slope form. You'll be practicing that today. There is no review preview. We're not going on to section 6.1.4 today. We're going to just do the Delta Math assignment. I hope you have a great day. Thank you for coming. Thank you for carefully listening to this, and I will see you later.